quiz?
No.
No?
Preferably no.
Preferably no?
Yeah.
But then you gotta show me what you remember.
Quite possibly. Quite possibly.
Okay, so I won't give you a quiz today, but I'll give you a quiz.
That's fair. That's fair.
So let's see. I believe that we talked about nuclear. Everybody has their periodic table, right? So that's pull it out all the time. What's that? Okay. So for these two, can you guys tell me how many protons, how many electrons, how many neutrons, the mass number, the atomic number, and the atomic mass? Yes. Yes. I know, we're using. Right, what's that?
Is it still train?
What's yeah, there's.
Oh, yeah, we got it. Yeah.
Yeah, so you have to use that, and then you're looking for. Yeah. You know what?
Um,
48.
Protons.
And 45 electrons.
45 electrons.
Yeah.
Sure. I'll write it down if you want to write this down.
So you seen that, are you sure?
No, I'm just asking, are you sure? Are you confident?
Yes.
Okay.
Six neutrons?
Yeah, hi. Oh, hi.
You're gonna need to do it all, so.
What's that? Hey, what about the mass number? Oh.
Oh, that's right.
What about the atomic number? You said, what was it? Not sure. No. And its atomic mass? What was that? 114. Good job. Okay, what about PT plus 4? Since you're yawning, you have to donate. Thanks for the cause. So.
For PT with a mass number being 195 as well. And then for electrons, would it be 74? Protons 78. One seventy, yeah, 117 for neutrons.
Yeah. Say it with such confidence. 70. Okay. Any questions on this? No questions? Everybody got it? Feeling confident?
Would this have been the quiz?
This would have been the quiz, yeah. And
I'd
four
like to
other
retract
questions.
my statement.
And four other questions. Okay. So. Okay, so. Oops. Okay, so I believe we've gone over this. Slide, yes. Okay. Are there any questions on ions? Anybody have questions on ions? Okay, how do I know group two ions are always a positive charge?
Looking at the.
Yeah, besides looking at. Group two ions. Just testing the waters here to see what we've talked about, what we haven't talked about. So let's go to the periodic table. The easiest way is to look at the periodic table and help us through this process. I feel like I haven't seen you guys in a week. It has been a week. Yeah, that's right.
It was Wednesday.
That's right. That's true. So that's why I'm feeling so out of sorts here. Okay. So if we take a look at the periodic table. We talked about, I believe we talked about being like the noble gases, right? Everybody wants to be like the noble gases. They want to try to find a way to be like the noble gases. So there are three ways to be like a noble gas, right? One of them is by taking electrons. One of them is giving electrons, and one of them is sharing electrons. So those are your three options: either taking, giving, or sharing. Okay. So if we take a look at group two metals, they have an option. They can either take or give electrons. Okay. So if they're taking electrons, they're going to have to go 1, 2, 3, 4, 5, 6. Let's say we're talking about sodium. Magnesium, right? Magnesium. So that's 1, 2, 3, 4, 5, 6. So you have to gain 6 electrons. Right? Or they can lose 2 electrons. 1, 2. To be like neon. Okay. Now, if you think of it like this, in terms of energy, if you have the same store, one that's 2 blocks away and one that's 6 blocks away, and it's hell storming outside, right? Are you going to want to travel 2 blocks or 6 blocks? 2 blocks. Why?
Closer,
And
safer.
and was that? And less energy, right? It takes less energy, right? So at the end of the day, it's because it takes less energy, right? So the atoms are going to be much like us. They want to use minimal amount of energy to get to where they're going, right? Okay. So you always want to think of it as losing the least amount of energy. It's easier to lose 2 rather than trying to gain 6. Does that make sense?
Yeah.
Okay. So if we have aluminum here, what's going to be the charge on aluminum? +3. Because it's easier for it to lose 3. 1, 2, 3 than to gain 1, 2, 3, 4, 5. Okay. What about sulfur? -2, right? Because it's here. 1, 2. Right. What about arsenic? -3. Okay. So generally, this is a rule, right? There's a general rule. Okay. So when you start talking about metals, metals are always going to try to get a plus charge. Now, when we start talking about those transitional metals and those post-transitional metals, these guys here, right? Those guys are they obey their own type of rules. That's part of the reason why they're kind of isolated, right? So remember when we talked about the main group and everything like that, we kind of isolated them, right? Transitional metals have the ability to have change associated with it, right? So they can have multiple charges that are associated with one metal. Like for instance, if we have iron, iron can be +2,
Yeah.
it can be +1, it can be +3, it can be +4, it can be +6, right? Now, some of those are more common than others, but they have the ability of doing that. And so the way that you decide what they are, is by who they're going to be carrying out, right? And it's not rational, right? They find a way of being stable depending on who they're carrying out to. Okay, so that's what they do to get their stability. So they're going to be exceptions to that rule, right? So if you think of it, transition in general means change.
Yeah.
The fact that they can change their charge. But it's always going to be a plus charge, or I should say, most of the time it's going to be a plus charge. Okay, there might be a couple of them that will be exceptions. We'll talk about that. Okay, questions? Okay, so let's see. Now that we kind of talked about that, let's also talk about that concept of giving and taking. So what really happens in the case of sodium, right? Sodium loses that one electron, right? It's going to have a plus. That means that somebody else is going to come along and take it. So usually there's a pair up type of situation, right? Because we know that like something like fluorine, if you put sodium around fluorine, it's going to form what we call sodium fluoride. What happens in that case is, go over to the board. So sodium is going to become sodium plus, and then it's going to have that electron that is able to donate, right? So that electron is going to be able to donate somewhere else. Fluorine is going to become fluorine minus. So that electron that sodium is donating is now going to go to fluorine, and it's going to become a minus. Okay, so how many of you guys dated in high school? One person, two people. Anybody else date? Any of you guys date now?
Yeah.
She raises her hand slowly. It makes me question, huh? It makes me question it. Well, at least you're not like another one of my students. She was like, I'm here to get a husband. So, she was working on that at that point, right? Anyway, long story. Okay, so now if we think about dating in high school, right? There's often we date and we date that person who's opposite of us, right? And you feel like, oh, wow, I met the best guy in the world, right? He is so handsome. He's just the best. And your mom was like, oh, she's so excited for you. She's like, oh, who is it, honey? Who is it? Oh, it's Jimmy. Jimmy Jones. Jimmy Jones? You mean Jimmy Jones from up the street? From the Joneses? Oh, no. No, you are not dating him. I will not have any of my daughters dating Jimmy Jones. That will not happen. And what did you guys do in most cases? What was that? You do it anyway, right? Okay, you do it anyway. And then, if Jimmy Jones was a perfect match for you, if he's that perfect charge for you, you guys balance each other out perfectly. You're the good girl, he's the bad boy, or vice versa. You may be the bad girl and he may be the good boy, depending on the circumstances, right? So, but you have to balance out completely. So if we have sodium, which is a +1 charge, and fluorine, which is a negative charge, those opposite charges are going to attract. And we're going to form sodium fluoride. You notice there's no charge associated with it, right? And so we would call this guy sodium fluoride. Okay, this here's the sodium ion. And this is the fluoride ion. So you notice it doesn't say fluorine ion, right? chloride ion. So what happens if it's a negatively charged ion? We put IDE at the end of it. If it's a monoatomic, what do you mean by monoatomic? One atom, right? Monoatomic basically means it's one atom or one type of atom. Okay, so it's a monoatomic ion. So we change that name, we use that fluor, and then we put IE in it. Okay. You guys get that? And so together it becomes sodium fluoride. Put it in a container with a small tea cups. They'll be in. There's a drawer next to the sink in the prep room. Yeah. So it'll be next to one of the sinks. It'll be like the third or something drawer. They'll be. Urine cups. Okay. Okay. So we were talking about that name, right? So if I have Cl minus, what would be the name of that ion? Chlorine or chloride? Chloride, right? Because we replace the iodine with IE. Simple. Not too bad. Everybody got that down? Okay. So the other thing that I want to talk to you about is we know that the positive, as you guys can see here, positive goes first. So when you're writing the chemical formula, positive goes first. You always want to hear the good news first, right? Then you want to tell me the bad news, right? So positive goes first. Okay. So when you're writing that, that's usually how I tell if people Google it, because there are cases where Google switches it and puts the negative first, and then they put the positive, and then I know that they actually done it wrong. They Googled that. Okay, let's give it a run. So if I have sodium and bromine, bromine. So what's going to happen here? I put those two together. They cancel each other out. Okay, so then they can. Okay, so then what will be the compound? NaBr. You know that sodium's going to form positive, the bromine's going to form negative. Okay, and then we're going to form, what's the name of this? Sodium bromide. Okay. Questions?
I have a question. So when it's negative, you change the bromine, you change it to bromide.
That's right. And it also, it serves two purposes in all honesty. It tells us it's the end of the compound, and it tells us it's negative. Okay, so let me say that one more time. The I serves two purposes. One of the things it tells us is that it's a negatively charged ion, or it can also tell us that it is the end of the compound, but it doesn't look in this case. Okay. In this case. Okay. Okay. Okay, we're talking about the different names, right? So the question is, or you guys, you're going to ask a question. That's it.
Oh, what about this one?
Oh, that was just what I was getting to. Man, it's like you read my mind. I know it's going all over the place. Somebody should. Okay, so what happens when it's multiple negative? Let's say it's oxygen. What's going to be the charge on the oxygen? And then you said it's going to be O2, right? Okay, so this is one of those cases. Did I tell you about the time I dated crackheads?
Yeah.
I did tell you about that time. Okay, so I kind of made an emphasis that, they were too much for me, right? So this is an example of them being too much for me, right? So we have 1 plus and 2 minuses. So that means that you're going to need 2 pluses to balance it out, because ionic compounds, and this is what this is. These are ionic compounds. They have to be neutral at the end of the day. Okay, so then I'm going to need another lithium plus to balance it out. So then my chemical formula is going to be Li2O. Okay, so when we have, is that not working? I'm just making it hard for you, aren't I? I know you're not wearing the slides. Yeah, shoes in the car.
No,
You don't have shoes in the car?
no, I
So-
was midway through the drive and I noticed.
Size shoe you wear?
Me?
Mhm.
9.
And they have some. Okay, so plastic pilot. Please. I get Venmo.
I don't have either.
What size do you wear?
I have shoes.
Okay.
I just also have shorts.
Oh, you have shorts. Okay, shorts would be okay, but next time, don't wear shorts. Okay, you have to stand up the whole time. Okay, so do you guys get this? You see how it works?
Which shoes?
Yeah, I'm talking about this here, but do you guys get the idea, right?
Yeah.
Basically? Okay, so I'm gonna put a couple up there, and I want you to figure it out. And I want you to give me the name. Oh, by the way, what was the name of this?
Lithium oxide?
That's right. Because we know the charge is always gonna be associated with lithium, if it's group 1 or group 2 metals, we're always gonna know those charges. Since we're gonna always know those charges, then we will know what it is, right? We'll know that it's gonna be just lithium oxide. Okay. Questions? So we don't have to say there's 2 of them, or anything like that. Okay, yes,
So it will be oxide because there's only this one oxide.
excuse me?
There will be oxide because this is oxide.
No, it's oxide because it's a negative charge. Right, I. Remember?
Oh, that's
But I that means. Okay, so what if I have, say, I'll let you guys write this down.
I have one question.
I don't think I have.
I hope so. So what if you have 2 positives?
But if I have 2 positives?
Yeah, would it still be, would you keep both names or we should change it to I?
No, if you have 2 positives are not gonna come together.
Oh, okay.
You understand?
Yeah,
Because
so
So it's always based upon ionic compounds are going to be dependent on them being opposite charges.
Oh,
right?
okay.
Because if they're not opposite charges, they won't attract, right?
Yeah.
It's kind of like us. I mean, really, if you think about most of the people you date, if you date somebody who's just like you, most of those relationships don't work out, right? Because they're just like you, right? They get on your nerves, like, you make you sick, right? Uh-huh. He's like, you heard that told you before, right? Yeah. And so we always.
Not like I said it too.
You said it too, okay, yeah. So typically, we actually always pick somebody who's opposite of us. And that's the same thing, ionic compounds, they have to be opposites, right? Otherwise, you don't get that attraction. Okay. Questions? Concerns? Cash? Okay, so let's give you guys another run. Since you guys are feeling confident, right?
Yes.
So let's say we have calcium and nitrogen. First, tell me the ion that it's going to form, and then tell me the ionic compound that it's formed. And give me the formula M and A. So it's cool outside. It's cooler outside than it is in here. Dylan,
Is it calcium nitrate?
so tell me the ions of it.
Lots of calcium? See,
Okay. Somebody on that?
no. I lost lessons.
He says Ca plus. You guys agree with it?
Is it +2
So it's 2 plus,
or
right?
plus?
That's right. So it's going to be 2 plus,
Then,
and then nitrogen is going to be 3
yeah.
minus. Oh, this is a challenging one, huh?
Yes.
So how many calciums will we need to balance out how many nitrogens? 3 calciums?
Yes.
Okay, so I need
3 of each or
No.
maybe we need to.
I would need 2 nitrogens because we got this up, that's 6. And then here, that's positive 6. So positive 6, negative 6, that's 0, right?
Yes.
Okay, so then how would I write this?
CA2, no, oh wait, no. 6,
1, 2, 3. How many are there?
3.
3. Ca3.
Yeah. And then 3?
1. How many are there?
2 and 2.
And 2. Right. So we're just going to use the number that we actually need to balance each other out, right? So we need Ca3 and 2. So what would we call that? What did you just say?
Calcium nitrate?
Are you sure it's nitrate? Because you're changing things a lot.
Oh, no, I tried.
I tried.
Is it real?
I tried. Remember? IEE. Somebody raised their hand over there. Were you gonna get a quick
Yeah.
answer? Okay. I definitely put it in the very bottom corner, right? That's those limits there. Gotta learn how to use this board in the portion.
Maybe you could outline where the borders are.
Board is, yeah. But they erase it every day, so then. I lose it. Okay, questions? You guys see that? Okay, are you sure?
Just.
Sure. Good, good. Everybody good? Okay. Good. Okay, so let's try one more and then we'll move on. Okay, ready? Okay, so let's say we have aluminum. And cardigan. Aluminum and cardigan.
Yeah.
It should be. Yeah. Sure. How much do we have in that? Yeah, in the instructions. If not, check also on the other side, we have enough over here, because we have the nitrates over here. So if you did not put in the right place, you know what I mean? Right.
Plus three colors and a rim side.
Except for my.
Okay, tell me. Okay, so we're gonna be plus. Okay. Or minus. Okay. Like that. Okay. And then what would be the name? Okay. Everybody agree?
Yes.
So the nice thing about this is that we can do this, right? You guys used to do cross multiply and stuff like
Yes.
that. Big comment about it. You can kind of do this for chemistry as well too. It makes your life so much easier. Now, but you got to be careful because sometimes, let's say we had magnesium. Okay, so if we have magnesium here, what's going to be the charge on magnesium? And we had carbide. Let's do that. I'm going to do different colors. So what's the big charge on magnesium?
Positive one.
Say positive 2. And then carbon again is going to be. Okay. So then how many magnesiums am I going to need?
Two.
Ready? 2.
Yeah.
Okay, so then 2, C. So in that case, it'd be the cross multiply that we have. That would be a different concept. Okay, questions? Oh, what would be the name of it?
Yeah.
Magnesium carbonate. Piece of cake. Not too bad. Okay, so let's see if we can add another layer, right? Okay.
Oh, the
Old age or something.
You're only 21.
Yeah, it's only 21. Okay. So we talked about transitional metals. Now, transitional metals, they have to either tell us what they are, their charge, or they have to be determined by who they're with. Okay, so what do I mean by that? So if I have Fe plus, right, it's telling me that it's a 2+ charge, right? If I have Fe 4+, it's telling me it's a 4+ charge. If I have Fe 3+, that means that it is a 3+ charge. Now, we need a way of determining that because you can't just tell if I have iron chloride what the charge is. Okay. So the way that we do this is by using the Roman numeral. Okay, you guys know your Roman numerals?
Yeah.
Okay, we're gonna test it out.
That's one. That's two. Three. Four. Seven. You got it.
Okay, Thomas.
I had a good question.
Yeah.
So from five, from four basically confused by one B, B, but at nine, they do 10 minus one basically, right?
Same thing before, right?
Yeah.
It's just 1 minus 5.
So why do you like go all the way down to 8 and then just stuff like that?
Ask the Romans. I don't know. That was well before I was born. I know you think I'm old, but I'm not that old. Okay. Okay. So the way that we would do this now is that we would use that Roman numeral for the name. So then we would call this guy iron 2 because of its charge. Okay. So it's based upon its charge. Not how many you have, but its charge. Okay. So then this guy would be iron
4 ion?
4. Then this guy would be okay. Questions? Simple. Okay, so now we're gonna pair that up with stuff, right? See how much you guys know. Now again, this is for transitional metals. Group 1 metals are always going to be +1. Group 2 metals are always going to be +2. So we never do that. And then we know that aluminum is always going to be a +3, right? So you're never going to need it for those. Yes, sir. You want surplus. So let's make about how many moles will each? 25 moles. Okay, so then let's make there's 6 groups. There's 6 groups, yeah. So let's make maybe a 400, maybe 500 mole. Okay. Okay, so let's say we have so give me the chemical formula and the name.
See, I thought it was sweet.
So it doesn't hurt you.
Yeah.
Okay, you guys ready? Okay. Again, I'm here to look pretty. You guys have to do the work.
The formula would be FE2.
Iron and then 2 silicate.
So you don't have to carry over the ion? Like, you don't have to say ion, 2 ion.
No, you don't have to say, because now it's balanced, right?
Oh, I see.
Okay. You skate? Okay. Good, good. Okay. Try another one, just in case.
Yes.
Okay.
Is that an L or not? It's an L.
Volunteers.
I think I.
WCl3.
Hey,
So it's in
Tongue.
chloride?
Tungsten 3 chloride.
Oh,
yeah, tungsten 3.
oh, okay, thank you. So you helped me out.
Why is it 3?
Yeah, but
That's the charge.
plus it, 3 plus.
Tungsten 3. Questions? Okay, so now let's see if we can do this backwards. Then give you the chemical formula. I want you to give me the chemical name. Okay? Okay. Ready?
Yes.
Let's talk a little bit about metalloids. Metalloids. So what are metalloids? So they have properties of metals and nonmetals. Okay, since they have properties of metals and nonmetals, that often means that sometimes they'll act like a metal and sometimes they'll act like a nonmetal. So when they act like a metal, you have to give them their charge. You have to tell them their charge, right? They'll have a positive charge, right? And then sometimes they'll act like nonmetals, right? And so you need a distinction. Usually they're going to tell you this acts as an ionic content. Okay, so let me give you an example. So here's an example. So what would be the metalloid's charge in this case if it's acting as an ion?
Positive.
Positive what?
Positive.
Positive 4. So we'd have to say that it's positive 4. So we call this
Silicone one oxide. Silicone one oxide. Silicon one oxide.
Sure.
Yeah, the smiling face. So it's here now.
Are you scared? There's nothing to be scared of.
Is that, yes.
Anybody disagree? So right now, this is what we have. We have silicone one. You guys agree?
She does not see.
You don't agree?
I don't.
Oh.
Okay, you gotta give the right answer, as they said. Or an educated yes, right? No, so we're not gonna use try, right? Because you don't use the prefixes. Another thing. Yes. It would be silicone 6.
I'm.
You wanna know why, right?
Yes.
Okay, so tell me, what are the charges of the oxygens? Each of the oxygens has what charge? Negative what? 2 period. Don't just tell me the answer, look at the periodic table first.
-2 charge.
It's a -2 charge, so we have, how many of them do we have?
3 of them.
We have 3 of them. So if I add those together,
6.
it'll be a -6 charge.
Right, -6, yeah.
Okay, so if it's a -6 charge, then what, we only have 1 silicone. So what has to be the charge on that? Balance it out. It has to be a +6. Right?
Yeah.
Okay, so remember, Roman numeral tells me the charge here. Okay, you guys see that? Have that look. Can I do another problem? Sure. I can. What am I doing? Did you press the button? Okay, do we have some? Yes.
I guess, but I know it's not right. Because I don't know if it's supposed to be a. I don't know if it's supposed to be a negative 4 or plus.
The front.
So it's positive.
But is it a positive 4 or is it a positive?
Some positive.
So remember, if it's a metalloid, it's gonna behave like a transition metal.
Yeah.
So that means that it can have multiple charges. Yes.
12.
Is that
12.
12? Said Roman numeral 12? No, I just want to, is that what you're saying?
Yeah.
Okay, Roman numeral 12. So, value, right? So, what do you, well, you got 12, anybody else? 13? Now you're just guessing, right?
6.
6. How did you get 6?
Phosphorus has a -3 charge. in its
Oh, I
two
see.
nodes.
Okay, so we have to rely on its partner. Its partner is phosphorus. We know about phosphorus, right?
Yeah.
Phosphorus is going to have what charge associated with it? -3. That's right. So if it has a -3, there's 2 of them. So each of those are going to be -3, right? So then what must be the charge on this?
6.
It's going to have a
Positive 6.
Yeah.
That's what else, right?
Okay, so then the name would be
Germanium phosphide. Germanium 6 phosphide.
6. Phosphide. So what you got? Yes. Okay, yes.
So we rely on the charges, the so we rely on the charges of the
Yes. Yeah. So for the transitional metals, the metalloids, if the metalloids are acting like a metal, right? Then we're gonna rely on the other guy, right? We're gonna rely on the negative charge. Tell us what that means.
so let's say phosphorus hydrogen.
If there were 3 of them, yeah. Oh, no, that would be 9.
Yeah.
Okay, does that make sense?
Yes.
Okay, so yeah, so that is the one that's given to us. So we know what phosphorus is gonna be, always, right? Since we know what phosphorus is gonna be always, we're gonna use that one to help us figure out the one that's questioned, one that's changed. Does that make sense?
Yes.
Yes,
So that's how you figure out that germanium was 6.
6 plus, yeah. Because we know that phosphorus is gonna be a -3, right? So when it becomes phosphide, it becomes -3, right? Always gonna be a -3. So when there's 2 of them, so that's -3, so that's -6. So we have to balance it out completely, right? Remember, we have to balance these guys out completely for them to match up. Okay,
So like, germanium, like it has the 4 plus, but it's 6 plus 2. So
Okay.
we're relying on the order.
yes, because again, germanium is a metalloid, right? When it's a metalloid, when it acts like a metalloid, right? When it acts like a metal and it's a metalloid, it has the ability of being like a transitional metal. So it can change its charge. It doesn't have to be satisfied.
Gotcha.
Okay, so that's the weird thing, like the metalloids, the post-transitional metals, all of those guys are gonna behave weird, right? So they can change their charge. They're not always gonna do the same charge. So you're gonna have to rely on their partners to tell what charge they're. And that's the same thing with the actinoids and the actinoids. So the ones at the very bottom down here as well. Down at the very bottom of your PRI table.
Yeah.
Okay. So, let's do one more.
Yeah.
And then what we'll do, we'll take a short break. say 15-minute break to get some fresh air in this place, but it's stuffy. Okay, and then when we come back, we'll have to do some more, so I need to get you guys caught up with that. But we'll try to get you guys. Okay, so let's do one more and then we'll transfer. Yeah. That I left. Yes. 8. 8. Okay, so the charge would be 8. Okay, so tell me the name. Victor.
Europium 8, telluride.
Okay. Europium 8. Telluride. Okay. Hey, how are you guys feeling?
Pretty good.
Pretty confident? Good. Okay, so let's go ahead and we'll take a 15 minutes. Okay, 15-minute break. So then it's according to that clock there, which is it is 37. See you guys back here at 2:37. According to that clock.
It's correct.
Correct?
Yeah.
It's, it was 5 minutes off. I need to run to my boss's office and see if he's there. Then we'll come back and learn some more.
Awesome.
Yeah, the guy over there said no. People on trips. Or everyone else.
My brain's like. It's in your mind. See. It's in your mind. It will sit on this on the right. So much.
Sorry, I'm a little late. Got some good news. Get to fix a program. So it is a good thing. It's not a bad thing. Great. Okay, so you guys are feeling good? Got this under control? Yes. Okay, good. So let's add another layer. There's layers upon layers upon layers. Exactly, just like that. Okay, so we also have what we call polyatomic ions. What do you guys think that goes on? Four. Let's just be very general. One and two.
Oh, yeah.
So, okay, so what it is when you have one two elements coming together, and those elements are typically covalently bonded. You guys don't remember what covalently bonded means? Covalently bonded. They share electrons. Okay, so they're usually covalently bonded, but they also have charges that are associated with that covalently bonded compound. Okay, so in other words, yeah, phosphate and oxygen are covalently bonded together, but they still have a charge associated with them together. And that charge is on that whole thing, not on just one of them. It is the whole thing. Okay, so this polyatomic ion polyatomic ion is called phosphate. Okay. Now, when you see the ATE, it normally means that we have oxygen. Okay. These guys are also called oxy anions. Why do you think they're called oxy anions?
They're oxy for oxygen, anion for negative charge.
That's right. That the oxy for oxygen and a negative charge, and anion for the negative ion. You said it better than I could. Okay, so this guy, PO3 minus, is called phosphite. IT. Okay, so what is the difference between phosphate and phosphite? What was that? Different subscript. So specifically, what is the difference? One minus what? The oxygens. So we lose one oxygen, right? So the difference between 4 and 3 is the difference between 8 and the 8. Okay. Now if I go down one more oxygen, we call this guy hypophosphite. So in other words, hypo. Have you guys heard of a hypothermic needle or hypothermia? What's hypothermia?
Body's too.
Less.
Below temperature, right? So below temperature, right? So hypo means below, right? Okay, so hypo height. So below height. So it's one below height. Okay. Now if we go the other way, we add an oxygen to the phosphate, we call it perphosphate. Because when a kid gets too much candy, we call them hyper, right? That per, right? And so that you guys don't get confused with that hype, they use per for one and hypo for the other. Are you sleeping? Do you need some sugar? Need some energy, want some coffee?
I would love some.
I would love some coffee too.
So And the Mesa building, they have coffee. Okay, questions? Concerns? Cash? Okay. Can I use this part here?
Yes.
So if you guys go to page number 5, there on top of it, you have of your periodic table packet. Fifth page, I believe it's the fifth page. If you count 1, 2, 3, 4. Okay, so the common polyatomic ions. Okay, so these are the common polyatomic ions. So you guys, through using them, you should learn them. It's not page number 5, it's page number 5 back and forth. So like first page is 1, the back page is. Got it? Okay. Okay, so you should know these by using them, right? Again, you're not expected to memorize them right now, but over time you should actually start to know them. Okay, so if you guys do me a favor and take a look at SO for 2 minus, and what is that? Sulfate. So. Okay, so if I have 1 electron lower, I mean one oxygen lower. So 3 minus sulfite. If I have 1 more than that. Sulfite. Okay. If I have 1 more, sulfate. Okay, you guys see that trend? Okay, now this can be done with all of the ones that are your common polyatomic ion table. Not only that, this kind of gives us guidance to other elements that are in the same group. So those that are in the same group will behave exactly the same way. Okay, I'll repeat that. All right. In most cases except for nitrogen. Nitrogen is that rebel. Okay, in most cases except for nitrogen, those that are in the same group will behave exactly the same way. Now let's do the one for nitrogen. What is so this first one would be called per nitrate. Okay, the next one would be nitrate. Nitrate. And the next one would be nitrite. Nitrite. Hypo.
So why doesn't it go like when? What does it have like?
What do you mean by that?
What is the negative? Just like that.
No, it just has a single one.
Oh, so it doesn't have to have one right there.
No, because it's understood anytime you just have a negative, it's understood.
Oh, okay.
Because you're saying I have 1 negative, just by having 1 there, I have 1 negative. Otherwise, we have two manganese. Okay, questions? No questions, everybody got it? So when we're working with these, and we put them with, let's say, a metal. So let's say I have manganese. Or sulfur. So what would the chemical formula be for that? Manganese or sulfur.
Is it Ng4S2?
And right down, you just told me. Say Mg.
Manganese? Oh, Mn.
Mn. Okay.
That's right.
Mn.
S, and then the 2 and the.
Says S2.
So screwed.
Okay, is that sulfate?
No.
What would that be?
Sulfide.
That'd be sulfide. I.e.
I see.
sulfide.
Yeah, I did it wrong.
Okay. So we know that that's not correct.
No.
So then how would I write that? SO4. Now, again, we don't want charges there because they have to balance each other out completely. So if we have manganese or plus, we know that that has a spore charge, right? So then how many sulfates do I need to balance it out?
1.
Sure, isn't this, what's the charge on this guy? SO4, what is the charge on SO4? Let's write this out. So we know that this guy is a what charge again? This guy here is a what charge for the manganese? It's a plus 4 charge, right? And then we know that the sulfate is a what charge?
-2.
-2. So then how many sulfates am I going to need to balance out that plus 4 charge?
2.
I'm going to need 2. So then I'm going to put parentheses 2. Okay, so again, it has to add up to 0 at the end of the day. It has to add up to 0 at the end of the day.
So basically, you're saying that you're going to multiply by 2. Okay.
So in other words, you have 2 of them, right?
Yes.
That quantity. Okay. Another. You guys got this.
No, sure.
Okay, so let's do. Bismuth. Phosphate. Bismuth, 5 phosphate. Bill Victor coming on? Have an answer from you, Victor.
Okay, I got business 3.
So what would be some for business?
BI.
I can't remember. BI, you said 3,
Yeah.
Okay.
Parentheses. EO. 5. 5.
those parentheses in front. Okay, you guys agree? Piece of cake?
Yeah.
Let's go for it, it's okay.
Okay, no, I got it.
What's that? Not enough sleep last night? Not enough sleep last night?
Just the weather change.
And also with some of this, all of the fires and stuff, that's. My eyes get all crusty and stuff. Okay, so are you guys feeling comfortable? Okay, I'm gonna add a whole nother layer. You want to do one more before I add another layer?
Yeah.
One more before I add another layer? Okay. Right. Excellent. Okay, so tell me the name of this compound. Okay, anybody have names for me? Anybody want to gamble? Gambling? Anybody want to take a gamble? Yes.
I think you got to get a guess.
Take a guess. I know Kevin knows. It's one of their teams.
Calcium 6 nitrate.
How did you nitrate?
Nitrite.
Nitride?
Like TAT.
TE? Because if it is a TE, that means there's oxygen.
Oh,
Is there not?
no.
Is there a magic oxygen that I don't see?
No.
No, okay, so it's definitely not that. Anybody else want to try to take a gamble? You guys look at your polyatomic ion table.
Yeah, and that's why I got.
Calcium two aza?
Okay, so would it be calcium two azide? Where's calcium located at? What was it? I heard group two. What do we know about group two?
They're playing earth metals.
And we know that they're always going to be what charge?
Plus,
Positive what? Two. They're going to be positive two, right? So do I need to put the two?
No,
So then the name should be
calcium azide?
calcium azide. That's right. Good job. Calcium azide. Piece of cake? No.
I mean, I understand, like, I don't get it.
You gotta use your periodic table, right? And you have to use your polyatomic ion table. How do you use both?
I usually both and I still don't get it right now.
Look at azide.
I'm not somewhere.
So can somebody help me out with azide? What does azide normally look like by itself? Single. It's an N3 minus, right? So this means we had how many of those?
Two.
We have two. We don't put in parentheses because it's only one atom, one type of atom, right?
Yeah.
So then we just use N3 minus, or 6 minus.
Yeah.
But we know that each set could be A minus because that's two. So it had to be. Okay. You guys see that? Because you need each one of these are a minus. You need two of them to balance out that plus two, right?
Okay, yeah.
Now you remember when we had, say we had calcium plus Cl minus, you know? Right? You don't put it in parentheses and put it two on the outside. You just bring it together. We just call this calcium chloride. Right? This guy is just called calcium azide. See that?
Yeah.
See it?
Yeah. Yeah.
Does it help a little bit?
Yes.
To break it down. Okay. Don't worry about it. Just think you're more comfortable with it when you use it. Okay, do you want me to add another layer? Or do you want to try one more before I start that next layer?
Yeah, just,
One more, just to be sure.
yeah, another one more.
Guys. Well, sometimes we need multiple one mores to get to where we want to be. Right?
Yes.
Not all of us are one and done geniuses. Let's take four. Okay, let's see. That's easy. Are you raising your hand? Sure you wanna raise your hand? Any volunteers?
Might as well answer. I don't know. I'll probably go. I don't know how to pronounce the first one.
Ethiopian.
Aluminum 3 hydrophosphate.
Three.
Okay.
Okay, let's think about it. Iodium 3
Hydrophosphate.
hydrophosphate. Are you sure?
Yes.
Hey, I want you to look at the poly.
It's hydrogen phosphate, but putting
You would put hydro. No.
see,
But it tells you what it's supposed to be.
the hydrogen phosphate.
Hydrogen.
So does it change it if you drop the insane hydro?
Yes,
Oh.
because that means something entirely different. So you don't want to do that. Don't assume.
All right.
Okay, you guys agree with it? Anybody disagree?
Really?
Yes,
So they charge us for no. Opium and.
yeah, so the charge for this is gonna be HBO4 2 minus, right? Okay, so then cross multiply, right? And then niobium is gonna be NB 3 plus. Cross multiply. Okay, questions? You guys see it? Here. Okay. Okay, so let's see, we're gonna add a layer. Ready to add a layer?
Sure.
Okay, the next thing we're gonna talk about are called hydrates. Hydrates. They're ionic compounds, we also call them hydrates. So when you hydrate, what do you add?
Water.
Water. We're gonna be adding water. So the way that we do that is, we put this big old dot, and then we put flow, right? So sometimes we'll add 1 water, sometimes we'll add 2 waters, sometimes we'll add 3 waters, sometimes we'll add 4, 5, 6, 7, 8, 9, 10, 13 waters, right? So now, when we do this, we have to use those Greek prefixes. Are you guys familiar with the Greek prefixes? So let me tell you about Greek prefixes. Roman numerals and Greek prefixes. Okay, so you see how many you guys have? So if I have 1, that's going to be mono. If I have 2,
Lie or die, right?
Sorry.
die. We die. If I have 3,
Right.
try. 4.
Yeah.
Tetra. 5. 5. Pent. 6. 7. Pent. Penta. 8. Octa. 9. Nona. 10. 11. Unde. 12. No deca. 13. Trideca. 14. Tetradeca. Okay. So if we were naming this guy, we would call this guy Novivian. Sorry. I'm screwing up. Novivian. Novirium. I'm screwing it all up. Niobium, sorry. Niobium 3 hydrogen phosphate. And then we put with water, we put heptahydrate. Okay, now the okay. Simple?
No.
Okay, so let me give you guys an example, right? Another example. You guys ready for another? We'll start easy. So if I have open it.
Oh, okay.
Okay, anybody want to tell me? This part here, first part is what? This part here. Barium chloride. And then this part here. Alright. This cake?
Yeah.
So we'll do one more, then four. Okay, we have a name. Okay, Steve. But all you guys yell at me at once.
Oh, I'm sorry. I'll be quiet.
Diachromate. And so, there you go. Okay. We're gonna have
I have a question. Do you guys do the hydrate?
yes.
Oh,
If there's water there, you have to, otherwise, what's the purpose of the number? if you don't know?
yeah, all right, that makes sense.
Questions? Concerns? Cash? Okay, so let me tell you a story. So I was and I was downstairs on the fourth floor of the stock house. Yes, the fourth floor of the stock house. Good. And there's this postdoc that had been there for a long time. I just started thinking about it. So probably it's been maybe 4 months, 2 months. And I was working, there's another one of my lab mates, you're not supposed to work lab alone. So they were there too, but they were across the hall. So just taking up each other. And all of a sudden you hear this exploding. Blew up, right? And I'm like, my first instinct is you hear something explode, you get out, right? I'm not going towards the explosion, right? So I take off out of the building, right? Get out. And then as we looking back, we see the fire department, everybody coming, and everything like that. So once the fire department gets there, I'm like, okay, so there's nobody shooting or anything like that. But it was a really big explosion. And then part of the building was gone. And so the grad student was working with sodium metal, and they had a lot of it. And they were doing some type of synthesis that involved attaching sodium to protein and stuff like that. So they're supposed to be working with a anhydrous. Anhydrous means
Repels water?
anhydrous means you remove the water. Okay. So if we go for from something that has water to something that doesn't have water. And we get there by getting rid of the water or off the water. We call it anhydrous, right? And a good technician writes down anhydrous to let them know that the water has been removed. Now, I don't know if it was the grad student or the technician, it was supposed to be anhydrous. And he just took a solution, the protein that had water still in it. It was supposed to have all the water in it. Because sodium and water, large quantities cause a nice exposure. And so it basically blew outside of the water. A pretty thing. So, and that's because either he misread or didn't pay attention to whether it was anhydrous or it was a. Okay, so if we go, we'll start off with water, and we go to something that doesn't have water, we call it anhydrous, to let other people know that we've removed the water. So if you were a crappy technician and you just remove all the water, we know who to blame, right? We're going up half the building. Okay, you guys get that?
Yeah.
So that term anhydrous means without water, you remove water. Okay, so you need to know that one as well. Okay, so I'm going to take a step back. I got ahead of myself. And we'll keep going forward. So I told you when we have atoms that are in the same group, they act similarly. Right? I did tell you guys that. Okay, so let me give you an example. So if I have I have this ion. What is this ion called? Atomic ion. Think about who's in the same row as tellurium. Who's in the same row as tellurium? Same group as tellurium. Sulfur. Okay, so what would this guy be called? Sulfur. This guy would be called sulfate. Sulfate or sulfite. I or A? I. Okay, sulfite. Okay, so then what should this guy be called?
Tellurite?
Tellurite. Okay. So you notice same charge, same charge. Same name. Same entity, same entity.
Yeah.
Okay. So if I had what would be this one. That's Ag. Tellurite. Okay. See.
super acidic. Oh, no, I see the other one. Try that. I see,
You're in the middle entirely.
yeah, I did see it.
I'll write down the pack. Or- Coalinga. Or arson. Okay, you guys get that? You see that?
Yes.
Two major more. Well, one is really. That's not the type you drop. Back thinking. Yeah. Acids.
Yes, sir.
Everybody got this down? Come back to this. Okay, first off, the definition for an acid. Okay, so we're thinking about an arsenous acid. An arsenous acid is called a proton donor. Okay, what do I mean by proton donor? Okay. Okay, H plus. How many electrons does H plus have?
Oh, wait.
Zero. Look at your periodic
Yeah,
table
yeah.
before you answer.
Yeah, yeah.
So how many did you say?
Zero?
It has 0 electrons. Okay, so why does it have 0 electrons? Normally, 8 hydrogen has how many? 1, right? So if I remove 1, it has 0, right?
Yes.
Okay, so then how many neutrons does H plus have? Neutrons. 0. And how did you calculate that?
I just did one.
And then how many protons does it have? So what am I donating if I'm giving you an H plus? A what? A proton. Hence, proton donor, right?
Yeah.
So when we talk about a proton donor, we're making reference to that H plus. Now, hydrogen is a special case. Hydrogen will act like an ion when it's in a aqueous type solution. What do we mean by aqueous?
Liquid,
Not just liquid, it got to be a specific liquid.
water,
Water, right? So if I'm in water, right? Aqueous, right? Okay, so when I refer to an acid, often I will say H2, right? And then I put U at the end. Okay, this is now an acid. Let me know that it's an acid. Okay, so literally what happens is that we take this often as a gas, we bubble in that into water, and then you get some separation that goes on, and you end up forming that H plus. Okay, so we take this guy as a gas. Yes,
Can you repeat that statement where you said hydrogen will act as the what?
as an ion.
Oh, okay.
An ion. Hydrogen acts like an ion. That's the reason why it's lined up with group 1 metals, because group 1 metals have a charge associated with them. Say again? How many positives? One
Wait,
positive.
which one?
Group 1 metal. Group 1. Group 1 metal has one positive, right? So they're going to act just like it. Hydrogen is going to act like that when it's an acid. Only when it's an acid. Okay? And when we're using, damn, spill. All right. When we're using the Arrhenius definition, because there are other definitions of acids. You have to broaden it from. Okay? Are you guys with me so far?
Yeah.
Okay, so now to name this acid, we're going to use the name that it has. We know that this guy was rain tower, okay? SO3 2 minus, right? SO3 2 minus was called what? Sulfide. Okay, so if it ends in IT, right, we're gonna call it here. I'm gonna add an OUS. And here you'll notice we even added that R back to make it sound a little more fancy. Okay. Now, that's not always the case. Sometimes we just use that prefix. And we'll just put OUS. Now, if it's so fake, ATE, we're going to call this guy sulfuric acid. Okay, so if our little polyatomic ion is a sulfate, then we're going to call it sulfuric acid. What is this guy called? S2 minus. What? S2 minus is called what? Sulfide ion. Sulfide ion, right? Okay. So if it's a sulfide that's here, we call this hydro sulfuric. Okay. Okay, so if you guys look at the side of your polyatomic ion table, I8 organic pathways. Right? Then poisons. You guys see that? Okay, it, is. Okay, my other one is my rye as hydraulics.
Oh my God.
I know it's misspelled. So we use it. Okay. So you guys want to get this a trial run of the trial balloon here? Yes. Gray hairs coming in and everything. His hair actually started out dark brown and everything, and now it's all red. Gray hairs are starting to come in a little bit. Just a reason. Is that? Yeah, just a reason. Presents. Presents. We have
Yeah, that's,
And then there's four trays. There's four trays. You want me to get
So
those
that
for you
would.
right now?
Yes.
I don't know if anybody's
Solo.
in there, so I'll go see it.
Okay.
It's almost four, so they've already have those. I don't know.
Okay.
So if you go for the three, this one, right? The O three, would take-
They're a little bit less than that. They're stacked, so- So, okay, I'll go-
Go ahead. The spray cleaner? I do.
That's what I'm getting. Yeah. But I don't think this is just.
Oh, no, no, no.
That's what I got, that's what I got. I corrected myself, okay.
Sorry, I just got on it, so it's a bit.
I know, I was like, oh shit. No, I know, but like. What would you say? She educated guess? See, I'm having trouble with the name itself. I know the end of it. However, I don't know if that is how you say or spell it. So,
Thank you.
I. It's. Or.
That's what I'm.
This is like which spelling?
See, I don't know how to spell it. It sounds like.
Okay, guys, ready? Hey,
See, that's what I'm going with the actual name. of it. Just a spelling different.
Yeah.
See, I put those like that. But I kept the I.
hey, ready?
From this.
Kevin, they're throwing you under the bus.
It sounds better with the I. Not so much.
Busy Kevin. It's the.
Sometimes my
Bonus. Oh, no, okay. Oh, yes? Okay.
Hey, I got it. Thank you, sir.
Just spelling it out.
Even though I did all the talking. Appreciate the help.
Okay, one more, and then four. Action.
Probably.
Okay, you got some answers?
Yes.
Okay, let's give you some of those guesses. Anxious to hear. What about the first one?
Okay, so for the first one, I guessed, right? You gotta make sure you, I guessed,
Okay.
phosphoric acid.
Oh, her. That's 6 moles.
There's 5, or there was 5 ordered, and the only thing is.
Okay. Thank you. Next one.
Oh, no, I didn't even, I struggled on the first. Give me, give me second, just the first answer.
Hey.
Okay, so who is it? Who is the answer? Everybody's looking away. You're not supposed to look away. You're supposed to- as soon as I look at him, he's like, nah. You want it? Okay, excellent.
Hydrophosphoric acid?
Hydro. Phosphoric. Okay, so the other thing that you want to pay attention to, if there's no oxygens there,
That's what I'm.
yeah, remember you're going to use hydro. That helps us remember that there's no oxygens there. That's why I told you, I want you to use hydro unless you're. Okay, this last one. Who's gonna be the champ? Oh, she's going for 2.
Hypoiodous acid?
Hypo. So I notice that. Okay. John. Are you guys feeling confident? That's all one word, the hypoiodous and then acid.
That
Yes.
last one, the height one.
Yeah.
Can you break it down to that?
Okay. So I know if it's IO 3 minus, that's called what? IOD. Okay. If it's IO2 minus, I mean IO. And if it's IO. IO. IO.
Oh, I see what you're saying.
So it ends with the ITE, so then I have to replace that with the US,
Oh.
and I get my answer. Okay, questions? Concerns?
I would say,
Cash?
I need cash, but
We all need cash. Okay. Guys ready for the next level? Oh, this is the hardest one, hardest of them all. There's more. There's more. And you guys, this here is just inorganic nomenclature. Wait till we get to organic nomenclature. Okay, guys, ready?
yes.
Okay. So when things are covalently bonded together, and that ion. So. Okay. So this first one is called carbon dioxide. So here we're going to be using the Greek prefixes. So for covalently bonded compounds, we use Greek prefixes. Okay, you don't use mono if there's one on that first element. You only use mono if it's on that second element. I'll just give an example. Okay. So we just would call it carbon. So the second one. You guys think that is nitrogen what?
Answer?
Nitrogen. Dioxide. Okay, what about the third one? Nitrogen, oxygen,
Iron, right?
fluoride.
Oh. That'd be,
What about this one? Carbon. Mon. Oxygen. Okay. Now you'll notice I didn't put mono oxide. Okay. With the oxygens, you drop the valve and you only use that O from the oxide. Okay. So what if I have this one? Yeah, now you guys all know what you want. Calm down.
Sulfur.
How many are there?
So 6.
So how would I say six? How?
Hexa.
Hexa, hexa,
Extra sulfur.
sulfur,
Octofluoride.
octa. All right. Now you'll notice they all end with I. I lets me know that it is the end of the compound. So if I have okay. So it can go on forever, right? Until I get to my I. That's the end. So this guy would be, it goes crazy. It would be
Dicarbon.
Tetra.
dicarbon,
Tetra.
tetra,
Phosphorus.
phosphorus,
Tri.
nitrogen,
Oxygen.
oxide. Or would I actually say oxide or would I say
Monoxide.
monoxide? Okay. Piece of cake.
A lot of writing.
That is the one.
Okay. So we're gonna play a game. You guys ready to play a game?
Yes.
This is the way it works. The team that gets them all right, they'll get 2 points extra credit. The team that gets in second, that gets them all right, will get 1 point, not a dollar. 1 point extra credit. And the team that gets them right, all right, they get to go, right? Team that gets in second, that gets them all right, will get 1 point extra credit. And the team that is just out of luck, they're out of luck. Now, it is a relay race though, okay?
Huh?
A relay race.
Oh, okay, yeah.
A relay race. Okay? So this is the way it works. So your marker is your baton. So you go up there, you write down the answer to that first one. Then you pass it on to the next person in your group. They write down the answer to the second one. Then you pass it on to your group. Then they write down the answer to the third one. Until you go through, and then you flip all the way through, right? You go all the way through.
Can you hand it
And
to
wait.
each of ourselves?
No. You have to be in order. It has to go in order, right? And you got to take turns, right? Okay, now once you've answered them all, right? Once you've answered them all, I will give you guys an opportunity to go up there together as a group to go through it up there and correct them, right? As a group, after all of them have been answered. Now you can't discuss it while you guys are doing it, right? You can't discuss it while you're doing it. You get a chance to discuss it when you guys get up there in the group. Okay? You guys look stressed. Don't stress. What's that?
For this, they're all available?
You said they're all gonna be covalent. No, it's everything. We're covering everything. Everything, right? We're covering everything, right? Because you guys start. This is a learning process, right? This is a give and take, right?
All right.
Okay, you guys ready? Or you guys can handle it, right? Okay,
Can we take the periodic table with us?
when you go up there?
Yeah.
Yeah, you can take the periodic
Oh,
table.
perfect. That makes it easy.
Yeah, I was like, I don't remember all of them.
Okay, so we'll have, you guys have little boards right here. That's your board number 1, right? So this will be this first group. We have 3 groups. We're gonna number you guys off. So I'm breaking up the teams.
Oh,
I'm breaking up your families here. Okay,
Oh.
so you're 1. Repeat after 1. 3. Yes, 3. Now say it.
I am number 3.
3. You're 1.
1.
3.
Okay, so 1s are gonna be here. 2s, you guys gotta come up here. And threes, yeah, you guys, that's gonna be your board.
I'm chilling.
Okay, so ones are it looks like green on the board. Ones. And then twos, you guys are gonna be purple on the board. Who's twos? Who's twos? Okay, twos. And then threes are gonna be red on the board. That's the way color shows up, red. I'm giving you red. We should show up red. Okay, you're three, right?
Yes, sir.
Okay. Okay, so let me erase these and I'll put the questions up. Okay, you guys ready, right? You feeling confident?
I'm ready.
Can you do me a favor? Alicia, there's also go and make a ratio next door. Okay. You got it. Okay, so this is your spot. This is your spot right here. Okay, so let me put them up. Yeah, move this out of the way. Yeah, we did this in Zoom. Mauricio was in my class. Yep, I heard my name. What did I do now? Okay, guys, ready? Yeah, get to number 3. Are you guys ready? So how do you guys make that?
Yeah, I did.
We can't.
Like what order?
On your mark, get set. Oh, it's already up there.
You can go this way.
Go. So those are the 15. 15 go.
Okay, so just go out the door. And then keep going. So you're last, so every fifth one.
So you can't discuss. First person who has the second round, go up there. Discussions. Discuss at the very end. First question. Okay, number 1.
Yeah.
For me, Mauricio.
Since I give the keys already.
What's that?
But I actually give you the keys, the one you have.
Oh, yeah, you did. Read the already. I was talking about that. There are questions.
For that one, did we just put like, the binary or?
You know the chemical formula. So if you're given the chemical name, you need to give it the chemical formula. Look at your periodic table. Do you see a lowercase a lowercase a, or a chemical formula?
No.
Okay, so then that's not the chemical formula. No, that is not the chemical. AQ means aqueous. right? Is that the chemical formula? Like, for instance, if I was writing the chemical formula for sulfuric acid, I'd write H2SO4 AQ. That would be the chemical formula. I want you to give me the chemical formula.
Oh.
Don't look at their answer.
So.
Okay, who's next on your baton over here? You gonna pass it on to somebody else? Okay.
I thought it was that.
The next purple group, purple team, purple. Put yours up there. Come on, it's a relay race. Come on now. Remember, you get a chance to discuss it afterwards. She's like, why did I do number 2? Green, green, what's happening here? Green.
You got it?
Okay, wait. So you have to go in order. Is that number 2? Are you sure? Because look what number 2 says. Okay, red. Who's the next one? Pass the baton.
Pass it to them, bro.
Somebody did. Somebody went up there and wrote the first one.
That was me.
Oh, that was you?
That was me.
Okay, so then
I left that right there.
Kevin, you go next. Green, what's going on? Stalled. We got one answer. Come on, team, go.
They have to be put up in order, right?
Yes, they have to be put up in order. Yes. They have to be put up in order. So each of you guys take turns. So who was the next? Who's the next in line? You did the first one? Who did the first one? You did the first one? Come on, you can do it. Come on, go team, go. What do you think your money on? You think it's gonna be purple? You think it's gonna be green, or do you think it's gonna be red? Think they're using out? Okay. He's just trying to be nice.
I was gonna say it's either red or green. So then I looked at the purple they have up there.
Okay, third leg of the relay race here. This is the third leg of the relay on purple. We're working on a second leg. Come on, second leg. You're just behind. Come on now. Go team, go. Those square flags, those square flags.
Got it?
Well, I'm gonna say catch the light. You don't have your polyatomic ion tape? How do you do that? or do you have it back here? You thought you did?
Normally bring.
So for an 8, do we have to give you the name?
So 8, you would have to give the name.
All right, perfect. That's you can-
Hey, who's at the 4th leg here on purple? Come on, 4th leg. You guys are falling behind. They're already on 4. Come on, teams, let's go, let's go. Come on, you need this pressure. This is building you guys up. Are you guys stressed? Don't stress. Come on, you know, but you gotta learn. You gotta be in pressure. That's life. Okay. You got this. You got this.
When they're all done, we can like go off and.
That's right. You guys can talk to each other after you're all done. That's why you want to get them up there so you can. Go team, go. Come on, 3rd leg. Come on, come on. They're on their 5th leg. Oh my gosh, 5 legs in. Come on, purple team, you're falling behind. Come on, purple. Hey, you can't communicate with each other. You gotta do it yourselves. No, come on, that 4th leg. Gotta watch these guys. They try to cheat. Ooh. Purple team was falling behind. That's the move. Oh. Come on, red team. Come on. You got to keep that lead. Come on. You're on that 6th leg. Come on, 6th leg. Let's go.
We're waiting on 6 leg
Okay, purple team got their 4th one up. Looks like the red team is struggling on the 6th leg. It's some troubles. Come on, green team, let's go, green. We're on the 4th leg now, 4th leg. Uh-oh, purple team gets to the 5th leg. Uh-oh, red team, you guys. Yeah, we're on 7, we're on 7.
Oh.
Come on, green, come on, green. Yes, 7. I mean, look on your, look on. Thank you. You were exactly what I was saying. Yes. So AQ means aqueous, and then G means gas.
Also an acid.
So no, it's not an acid. Aqueous is only for acid. Okay, so if it's G, so if you guys have a G or an S, that either means that it's going to be salt, if it's an S, a solid. S stands for solid, G stands for gas, L stands for liquid, AQ stands for aqueous. If it's aqueous and it has a hydrogen, it's going to be an acid. If it doesn't, then you can assume that it's not an acid. And then it's no, sir. Okay, green team is picking it back up. They are at 5. They're going up to 6. Oh, it's a race. It is a race. I'll make this. Sir,
I know, but did we even discuss with the chief?
yes, I did discuss at the very beginning of the session.
Really?
Yes. You can stay up for gas. Told you that. Gas. Aqueous. Probably something. Yeah, pretty easy. Oh, by the way, who's gonna form covalent bonds, by the way? Metals or non-metals? Or is it metals and non-metals, or metals, non-metals and non-metals, or metals and metals? Who's gonna form covalent bonds? Didn't we talk about stealing somebody's bicycle?
Yeah,
Okay, think about that. I'm gonna say,
now your name, I thought that was the cross, so gas is it.
they form ions, right? Okay, because that's give and take, right?
Yeah.
Okay, so you don't steal from your neighbor.
Still from the cross, yeah.
Okay, so non-metals, non-metals. Form covalent bonds.
Yeah.
Okay. So I'm just saying. Come on now. That's why you're doing it. Because, yes. Let's see, go. I got two set on. I'm going, you know what, I'm gonna go with purple because, although, oh, wait a minute, hold on, I might go with green. Green is just like kicking butt now. Green is at 8, we're at leg 8 at green. Green is whooping butt, it looks like. Come on, red, what's going on there? Keep a pause in there. All it out, you guys got this, come on. Okay, purple's at 8. Oh, purple's gone to 9. Go purple, go. Red is stalled out at 7. Come on, 7. Let's go. I know she's got it. It's there. Yeah, got it. Think about what's all of those guys that are there. Think about the dual characteristic of hydrogen. You have a tape. It has an index. What does that mean? Come on, you guys saw that at 8. Come on, get those legs moving. Let's go. Go team, go. Come on, green. Gonna let purple beat you? We're at 11. Purple is at 11. Of course, once the discussion is like, red is stalled out at 6. Green is stalled out at 8. You were not listening to me, but I told you. Your hands. Snake in the fight chair, right there.
I prefer that at this point.
Tell me what all of those guys we have in common. Okay. Are you sure? Look at your periodic table. Because the periodic table tells the truth. You're right. Come on, Green. Come on. You guys got this. Number nine. You got this. Same group, I'm gonna behave like. Okay, purple, you guys gotta finish. You guys gotta beat by a yard. You have plenty of time to discuss your answers. Come on. Come on, purple. Come on, red. You got this. What did you call it? Ion table. Think about the different groups. It's in the same group, it's gonna be what? Purple's on 13. Green is on 11.
I was don't worry about it right now.
And come on here, come on here, you got this. It's about, and in the same group, and you behave like. Same group. We'll compare answers. Yeah, we'll require. Yeah. Red. Ooh, green is at 13. Let's get.
Purple's almost-
Purple's almost done.
No, they are.
So then they get to get up there and discuss it. Right over there. Break their hearts.
Back here. This one, like. yeah, we're good.
I think you better, I got some there.
Yeah. Yeah, it's about to do that. Those are your- I don't know, you do it. I don't know. What? Yeah, perfect. I was.
For that one,
Per.
for that one, I found a toy train, but then to compare it to like to go one level below.
Yeah.
I think that's for.
There you go.
You like this one?
Yeah, hypo, yeah. Oh, hypo. Yeah, so. Yeah, it's super. It's on the ring third bottom. Yeah, I don't know.
Oh, I got 11.
Oh.
All right.
All right.
That's great. You got it.
I was just reading. Yeah. Fine. Pick up the.
Let me know when you want me to come up there and tell you what you.
Dr. Minnie's number is 7 spell right on.
Yeah, yes. It's all right.
Oh.
What's that?
Yeah.
So we have all the.
Yep. I'll for you.
Yeah, okay. I'll put it on the. I think it's the number one. You got anything else? Oh, okay. That's fine.
have an idea about protein.
Yeah, yeah. Yes. Yeah. Yeah, that was good.
And then hypodermic would be 0.5. So you have down. So there's your hypothetical. And then you have to balance it. So therefore, therefore, so -2. And then H4. +1. So to balance it out. Two ammonia, to balance. Okay, then trade it. I swapped the carbon goes first. Do we put her? Yeah. So those obviously. And then go down one.
Yeah, it's nice.
Yes. Yeah. So, we're given nitrite +4, but nitrite. So to balance out the charges, you have to have 4 nitrite ions balance out a positive +4 ion.
That's right. That makes sense.
So that makes it cool.
Is it 6 5 6? Well, 5 is 5. 6.
I did not pick 7.
No, I did 7. You did 6. I think.
Acetate.
Oh, that's
There's acetate right here.
it's the first one of the. It's the first one right here.
That's acetate, not
I did.
acetate. So unless you spell that. wrong. Or that's something
Oh, that's
else.
fine.
There's an atom that has like acid.
That's what I'm saying. Right. They're 85,
We just don't put it.
85 is acetite.
Acetone.
Yeah.
So
So then that's the way
there's fluorine and iodine.
Okay, it's
So we'll
so
do
that's
fluorine
and dichromate or dichromate. That would go down to
There's all
IO3.
non-metals. So,
It should be.
1803. That's right. Acetate. And let's see. Yeah, that's what it's about.
So what's the charge?
Like ions. So that means that it would have a very similar to iodine. So same charge and not electrons. Because it has the same number of just
That makes sense.
and that has like just like plus two. So just one element already balances out. The number 8. I don't know.
And H is
Yeah, that roughly is definitely.
Is it NH?
No, NH4 is ammonia. So what is NH3?
Oh.
I just put nitrogen carbon. But I'm not sure if that's what it is. Nitrogen is a metal group. It's very.
So
That year, then.
But I'm not sure.
would it be nitro high?
What would happen if a non-metal is on its front?
Oh, wait.
Paired with another non-metal?
So. For which one?
For 8. I think we do treat it like a.
Are you guys ready?
Covalent bonds still is,
Say go for it.
So would it be?
I think I use ammonia versus ammonia.
Yeah.
So,
Okay. That's what you just.
This one is messing with us.
Okay.
Yeah.
Yes, you guys ready?
yeah, I think we're ready.
Okay. Let's see. We get
Oh, thank you.
my color shirt.
Yeah, Pino is blue.
It doesn't have water.
And phosphorus.
So you can't have one. So
There
you
is no
have
phosphorus.
Oh, she just. You guys ready? So try, yes.
So there's no flashlight, right?
No, there is no phosphorus.
I'll just tell you how many you got.
Rhodium 3.
Figure out which one it is. Yeah.
I know. Oxygen, sulfur.
The one we would probably have the most reference to is sulfur.
Sulfur, yeah.
Sulfur.
There's sulfur.
Sulfur.
No.
Okay,
And then persulfate would be
who's next?
S5. So,
Everybody next?
yeah.
And some of them are like really close, but. Yeah, take it. Yeah, you got it.
It's not. It's the tricky one. It's in gas form. And acids are only when it's in liquid form.
Don't let me get away with it.
I didn't.
Are you guys ready?
No. Number 2.
Not bad. Just the last year. Yeah. Yeah, yeah, for tomorrow. Yeah, I can do that. So that would be perfect. Yeah. Okay, okay, thank you.
With the S on it, no.
Okay, so what I need you guys to do is take a picture of your answers. Take a picture of your answers. Take a picture of your answers. We will finish this back up on Wednesday. Like, what's it, Wednesday? It's all a big haze to me. I haven't eaten at 5, so.
Do we erase it after we take our picture?
You can erase it after you take. You don't want anybody else to get your answers, right?
Hold on, I gotta grab my phone.
You want me to check you guys?
Yeah.
Okay. Did you guys want me to check you before you erase it? Yeah, okay.
Sure.
Leave it up and then I'll text you guys.
We're gonna be wrong.
Okay,